day, viewers. You're welcome to LJ Academy. Today we are going to be talking about mirrors. When we talk about mirrors, we have different types of mirrors. The two major types of mirrors that we have, apart from the plain mirrors, we call them curved mirrors, curved type. We have plain type mirrors and curved type. Under the curved type mirrors, we have number one, we have the converging or concave mirror. Converging or concave mirror. We also have diverging or convex mirror. So these are the types of mirror. You see the mirror as a kind of sphere that is cut into two. The side that is shaded on the outside, that is you are having the silver surface on the outside. This is the concave mirror. Then the one that is shaded on the inside, that has the silver surface on the inside, is called the convex mirror. See this point as the center of curvature. Center of curvature of this mirror. So there are some things, basic things that you need to know under each of these types of mirrors. We have this applied in different devices in our homes and around us. Okay, let's quickly talk about the technologies for mirrors. The number one is principal axis. I'm going to use a diagram to show you the principal axis. This is the principal axis. This is the pole of the mirror. That's the center of this mirror. Let's start with the concave mirror. We have the focus, principal focus. Another one is principal focus. Principal focus. That is the point to which all parallel rays of light converge, or from which they diverge. So, and a distance from the same distance we have between the pole and the focus is what we also have as the what? The same distance as what? The F, the principal focus, and the center of curvature. So, and this is what we call the radius of curvature, R. R, the radius of curvature, is the distance between the pole and the center of curvature. So we can say that our radius of curvature is 2 times the principal focus. Then this is what we call the okay, let's start with the center of curvature is like the point from which the mirror has its curve. Let's cut that out. So we have for the concave mirror, all parallel rays, this is the principal focus. All parallel rays run to the mirror. After reflection, will converge. Make use of arrows to show the direction of such rays. They are converging at the principal focus. This is for the case where we have the concave mirror. But in the case of convex mirror, the convex mirror rays after all parallel rays drawn to a convex mirror after reflection will diverge. So you're going to draw this way. So all for convex mirror, this is a convex mirror or divergent mirror. This is a concave or converging mirror. So you can see from here that all parallel rays that are drawn parallel, all parallel rays drawn to the concave mirror after reflection converge at the principal focus. Then for convex mirror, all parallel rays drawn to the convex mirror after reflection diverge away from the focus. So that's another thing you need to know on the mirror. Then we need to know the characteristics of images. Images of objects placed before a mirror. Now, this will take us to ray diagram, and we need to know this is a concave mirror. I'll be using a ruler. So you're going to make sure you measure. This is the pole. Measure equal distances. Let's say from here to here is 12 centimeter. So this will be 24 centimeter. This is our center of curvature. Label this as center of curvature, and label this as the focus, the principal focus. So what we're going to do now, let's test. Let's try and put an object. We represent the object with a ray line, a narrow edge line. If this is our object placed beyond C, now one of the rays that you're going to make use of to get the proper position of the image and the nature of the image is the parallel ray. So all parallel rays drawn, that is the rays that are parallel to the principal axis, after reflection pass through the principal focus. You pass through the principal focus. You draw your arrow line. All rays passing through the principal focus after reflection will move parallel to the principal axis. That's ray 2. Ray 1, this is ray 2. The last ray, which is not common, is a ray, any ray passing through the center of curvature will remain undeviated after reflection. It will go back the same way it came. So, but we don't need that now. So you just need at least 2 rays to construct your image position. So from here, where these 2 rays intersect is where your image will be. So this is the object, this is your image. And so what will be the characteristics of this? Let's take this as number one. Object beyond C. Object beyond C. You see this. I'll take this. So characteristics now. We have number one. This image is inverted. That is, it is turned upside down. Number two, characteristics, it is smaller than the size of the object. So we call that diminished image. Then number three, it is real. And number four, it is formed between C and F. These are the four characteristics we can say concerning the image of an object placed beyond C. It is inverted, it is diminished, it is real, it is formed between C and F. Let's not forget, you must know the difference between a real image and a virtual image. A real image is the image of an object formed in front of the mirror. It is at the same side as that of the object. But a virtual image is that which is formed behind the mirror. It is formed at the back of the mirror. That is, it is formed at the other side of where the object is placed. So, let's look at an object placed at C. Object at C. The first thing is to draw your mirror. Draw the mirror, then draw your principal axis, measure it, you can measure this. This is the focus and this is the center of curvature. I am drawing an object at C. All the rays parallel to the principal axis after reflection passes through the principal focus. Then the ray passing through the principal focus after reflection image. In this case, what are the characteristics of the object of the image formed by an object placed at C, which we call the center of curvature? Number one, it is inverted, it is real, it is same size as that of object. If you look at it, then it is formed on C. Formed on C. Also, let's quickly do an object between F and C. Draw your principal axis, you measure, place between, this is your F, this is your C. Image is rays parallel, passes through, ray parallel, passes through F. The ray passing through F so let's draw this, let's make it longer. So the rays intersect at these points. So this way your image is going to be. This is your image. In this case, the characteristics of this image, number one, it is inverted. It is a real image. It is magnified. And it is formed beyond C. Help you're getting this analysis. How these are simple ways of understanding the position of the image of an object placed at different points in front of the mirror. Now, what if we have an object at F? Make sure the distance between your P and F is the same thing as F to C. Distance between P and F is the same thing as F to C. If your object is placed at F, now rays parallel to the principal axis, after reflection, we pass through the principal focus. The rays passing through the center of curvature the characteristics of this image is that the image is formed at infinity. So note, whenever you have an object placed at the principal focus of a mirror, of a curved mirror, the image you're going to get is going to be formed at infinity. And this is used in different ways. Well, we will get to that when we start discussing about the application of mirrors and lenses. Okay, for the last case, you have objects between F and P. The object is here. Then the ray parallel passes through the finger of the principal focus, and you extend it with short dashes. Then the ray coming from the center of curvature the two rays met at this point. So we are going to draw it with short dashes. The characteristics of this image, this is the image, this is the object. So we are going to have what? Number one characteristics is that this image is erect. Erect image. A virtual image. Why is it virtual? It is formed behind the mirror. Sorry for this, I have not placed this. Virtual. Also, we have it is magnified. and formed behind the mirror. The last case for a convex mirror, in any position you place the object. This is our convex mirror. The principal focus is here, and center of curvature is here. If I place my object here, the rays parallel to this passes through the principal focus. Then, let's say this is the P, any point where you put it. Then we also have rays. Draw this. These two rays intersect at this, so you're going to draw a virtual image. So the characteristics of any image, any object placed in front of a convex mirror is that you always have characteristics. You have a virtual, erect, and diminished image. So you can make use of this acronym, VERT. Virtual, erect, and diminished image. So these are the characteristics of any image of an object placed in front of a convex mirror. Thank you for watching.